All right, so we're going to do the hydrostatic force problem that today in class was like, what is going on? And then we had to end, which I know is sad for some of us that we have to end class. All of you wanted to stay, and I appreciate that, but we do have to end sometimes. Okay, so this problem that we had with hydrostatic force, we're trying to look for the, oh my gosh, that's not what I wanted, I'm sorry. What we're trying to do is we're trying to find the force on a dam that's in the shape of a symmetrical trapezoid. Got used to writing with this thing again, so I'm sorry if the images look bad. So the dam's height is 30 meters. I know from here to here, the top side don't look at that, is going to be 40 meters long. Wow, I don't know why I cannot draw straight lines. And the bottom side then is 20 meters long. Now I want to find the hydrostatic force, so the force that the water is being put onto this dam. And so in order to do that, we need to know what water pressure is. So water pressure here is going to be the density of the water times the gravity that we have here on Earth. That's a y, not h. Times the depth. Now density and gravity, in this case, are just going to be constant, right? So we have 1,000 times 9.81. So we've got to figure out our depth. So at any given point y, and I say, well, depth of what? So what we're going to do is we're going to take this pen here. We're going to say, okay, we want to find this sliver, the kind of force that's being put onto that sliver of dam, if you will. And so in order to do this, what we're going to do is we're going to actually split this into its symmetrical. So we're going to split it in half this way, and then we're going to have y equals 0 right here as well. So we're going to put it on an axis. So this is y equals 0. This is x equals 0. But that's the y-axis, and this is the x-axis, okay? So that being said, okay, so I want to know how deep this is right here. So what I can do is I can say, okay, well, it's 30 minus y is how deep it is going to be. Because right here, it's 0, and right here, it's 30. So right here, it's 30 minus that y that we have. So the depth in this case is going to be 30 minus y. Because this right here, the value is just y. So what's remaining left over, how deep it is this 30 minus that part, and that's the part that's left over, the portion that's left over. So we're thinking, okay, we feel good about this. So then I say on, okay, well, what is being pressurized, if you will? And so what we have then is to say, okay, well, the area of this strip then is what's going to be pressurized. So the area of this strip that's right here. So what we're going to do is we're going to find the area of the blue strip and then multiply it by 2, because this right here will be how I can multiply it by 2. Okay, so the area of this strip is going to be, it's just a rectangle, so it's just length times width. The length is going to be this function right here. It depends on y. I needed to go an x. So I had to find a function that's going to describe this relationship on how this is changing. But the width or the depth of this thing, because it's so infinitely small, is just going to be dy in our case. So in order to find the length, that's the tricky part of this problem, is because this point right here is 10, 0, because we're at 0y, and this point right here is I've gone over 20 and up 30, because it's half right here. So that the whole thing's 40, I've gone over 20. The whole thing's 20, I've gone over 10. So I can find the slope of that line, and I can just do 30 minus 10 over 20 minus Sorry, it's not even 30 minus 10. It's 30 minus 0. Whoop. Sorry, it's the y values. Over 20 minus 10. That's what I get for talking and writing at the same time. So I get 30 over 10, which equals 3 is my slope. That's best 3 of my life. Great, and you can't even see it now. So then I can put it into point slope form, which is going to be y minus 0. I'm going to use this point right here. Is equal to my slope times x minus 10, or y equals 3x minus 30, which then, if I notice everything right here, that's all in terms of y, so I'm going to make this in terms of y as well and say, okay, well, that's actually then x equals, I'm going to do 1/3 times y plus 30. And the reason I'm going to keep it like this is because a third is just going to be a, it's a constant, so I can just pull it out when I integrate, and it's going to be great. So I have a depth, water pressure, so I have basically, I have density, gravity, depth, and what I'm going to be, um, that area, length times width right here. And I'm going to integrate this from 0 to 30. So the whole water pressure, or the force on the dam, is going to be this integral right here. Let me try that one more time. I'll get better with this thing, I promise. The integral from 0 to 30 of my water pressure, or sorry, my water density times gravity times this third, because it's a constant. But then I left with my depth, 30 minus y, times 30 plus y, dy. And that's just the difference of squares. So when I integrate it, I have my constant here, 1000 times 9.81 all over 3 times the integral of, this is 900 minus y squared. So I have, okay, 900 minus y squared. We're feeling pretty good about that. So then I say, okay, well, let's integrate. Oh, I don't forget my dy here. So I get my constant over 3. I'm integrating from 0 to 30. So this becomes 900 y minus y cubed over 3, evaluating from 0 to 30. And if you get here, you're going to be like, okay, yeah, now it's just plugging it in because they both have 0 here. So then I get this 1000 times 9.81 all over 3 times 900 times 30 minus 30 cubed divided by 3, which when you do this out, you will get about 1.8 times 10 to the 8 newtons of force. Now, the biggest thing here is this one asked us for force instead of work. So we have to remember, okay, if it's force instead of work, then I only need to have mass times acceleration. And in this case, like the pressure is basically as good what's going to be helping us out there to figure that out. And then you still have to know what is having that force being put onto with the hydrostatic force. So it's a little bit different than the work problems that we did with lifting things and pumping out stuff, but it's another one that you can have. And this video you can use on your exam and everything like that. So just make sure if you have questions, you can email me or let me know, and that'd be great. Good luck.